So, how did the solution go to the iron ore problem? We got this far already. Actually, we got as far as writing out the equation already and understanding what was being asked. So this is the final solution to the problem. And just to recap, we have some dirt, some iron ore, specifically 0.376 grams of iron ore. It's dumped into some acid, which allows all of the iron to dissolve as its 2+ ion. So that's aqueous. And then what happens is this aqueous solution of iron 2+ is titrated or added to very carefully to the potassium permanganate solution. And that solution concentration is known very precisely, and we know exactly and precisely what volume of that solution is used to completely react with this iron in a redox sort of way to convert all of the iron 2 to iron 3, and in the process produce manganese 2+. So there you have the given sketch of what's going on. The question is at the top: find the mass % iron in the ore. And our first step as a redox, after sketching out the equation, is to write the oxidation numbers. So there they are. We've identified the two half reactions and then split those into two and proceeded, let me just go this far right here. So we've worked up those two half reactions of oxidation on the left and reduction on the right, all the way to balancing the electron transfer, and then adding the two reactions back together, two half reactions back together, simplifying, and then restating the given down here. At that point, hopefully you got, this all looks familiar. You got that far. I can't fit it all on one camera look, so let me lift that up. It's still on the shaky table, sorry for that. And here we go. So now it becomes a conversion pathway problem, and we have the volume of solution in mils, 2 liters, and then using the concentration as a conversion factor, 2 moles of the solute, potassium permanganate, and then from moles of that to the moles of iron using the stoichiometry of the now balanced redox equation. Okay, because we can see in the balanced equation that 1 mole of KMnO4 reacts with 5 moles of iron. And specifically this is iron 2+. So if you wanted to put that in, that's specifically the kind of iron that is present. But that of course does not affect the mass right here, 55.84 from your periodic table. Okay, so there's 5 moles of Fe2+ reacting with 1 mole of KMnO4 in the balanced reaction, and converting moles of iron to mass of iron, we use the molar mass found in the periodic table. All the units cancel to grams of iron. Here it is with more than we need, significant figures, but we'll carry that in our calculator. Convert it to a mass %, so I'm putting the mass of iron over the total mass of the dirt, we called it, the iron ore. That becomes a fraction, multiplied by 100 is now a %. Trim it to 3 sig figs, and I think that's dictated by actually the mass of the ore itself was given to 3 sig figs, 0.376. So final answer, 65.6% iron by mass in the original sample of iron ore. So great question, good test question. Maybe a good exam question when we get there, and hopefully you arrived at the same result.